Section 11 of Your Mind and How to Use It by William Walker Atkinson. This LibriVox recording is in the public domain. Chapter 24. Primary Laws of Thought. In connection with this subject we herewith call the attention of the student to the well-known primary laws of thought which have been recognized as valid from the time of the ancient Greek logicians. These laws are self-evident and are uncontradictable. They are axiomatic. Jevons says of them, "Students are seldom able to see at first their full meaning and importance. All arguments may be explained when these self-evident laws are granted, and it is not too much to say that the whole of logic will be plain to those who will constantly use these laws as their key. Here are the three primary laws of thought. 1. Law of identity. Whatever is, is. 2. Law of contradiction. Nothing can both be and not be. 3. Law of excluded middle. Everything must either be or not be. There is no middle course. 1. The first of these laws, called the law of identity, informs us that a thing is always itself, no matter under what guise or form it is perceived or may present itself. An animal is always a bird if it possesses the general characteristics of a bird, no matter whether it exhibits the minor characteristics of an eagle, a wren, a stork, or a humming-bird. In the same way, a whale is a mammal because it possesses the general characteristics of a mammal, notwithstanding that it swims in the water like a fish. Also, sweetness is always sweetness, whether manifested in sugar, honey, flowers, or products of coal tar. If a thing is that thing, then it is, and it cannot be logically claimed that it is not. 2. The second of these laws, called the law of contradiction, informs us that the same quality or class cannot be both affirmed and denied of a thing at the same time and place. A sparrow cannot be said to be both bird and not bird at the same time. Neither can sugar be said to be sweet and not sweet at the same time. A piece of iron may be hot at one end and not hot at another, but it cannot be both hot and not hot at the same place at the same time. 3. The third of these laws, called the law of excluded middle, informs us that a given quality or class must be affirmed or denied to everything at any given time and place. Everything either must be of a certain class or not, must possess a certain quality or not, at a given time or place. There is no alternative or middle course. It is axiomatic that any statement must either be or not be true of any certain other thing at any certain time and place. There is no escape from this. Anything either must be black or not black, a bird or not a bird, alive or not alive, at any certain time or place. There is nothing else that it can be. It cannot both be and not be at the same time and place, as we have seen. Therefore, it must either be or not be that which is asserted of it. The judgment must decide which alternative, but it has only two possible choices. But the student must not confuse opposite qualities or things with notness. A thing may be black or not black, but it need not be white to be not black, for blue is likewise not black, just as it is not white. The neglect of this fact frequently causes error. We must always affirm either the existence or non-existence of a quality in a thing. But this is far different from affirming or denying the existence of the opposite quality. Thus a thing may be not hard, and yet it does not follow that it is soft. It may be neither hard nor soft. Fallacious application. There exists what are known as fallacies of application of these primary laws. A fallacy is an unsound argument or conclusion. For instance, because a particular man is found to be a liar, it is fallacious to assume that all men are liars, for lying is a particular quality of the individual man, and not a general quality of the family of men. In the same way, because a stork has long legs and a long bill, it does not follow that all birds must have these characteristics simply because the stork is a bird. It is fallacious to extend an individual quality to a class. But it is sound judgment to assume that a class quality must be possessed by all individuals in that class. It is a far different proposition which asserts that some birds are black from that which asserts that all birds are black. The same rule, of course, is true regarding negative propositions. Another fallacy is that which assumes that because the affirmative or negative proposition has not been, or cannot be proved, it follows that the opposite proposition must be true. The true judgment is simply not proven. Another fallacious judgment is that which is based on attributing absolute quality to that which is but relative or comparative. For instance, the terms hot and cold are relative and comparative, and simply denote one's relative opinion regarding a fixed and certain degree of temperature. The certain thing is the degree of temperature, say 75 degrees Fahrenheit. Of this we may logically claim that it is or is not true at a certain time and place. It either is 75 degrees Fahrenheit or it is not. But to one man this may seem warm and to another cold. Both are right in their judgments, as far as their own relative feelings are concerned, but neither can claim absolutely that it is warm or cold. Therefore it is a fallacy to ascribe absolute quality to a relative one. The absolute fact comes under the law of excluded middle, but a personal opinion is not an absolute fact. There are other fallacies which will be considered in other chapters of this book under their appropriate heading. End of chapter 24. Chapter 25. Reasoning. Reasoning, the third great step in thinking, may be said to consist of ascertaining new truths from old ones, new judgments from old ones, unknown facts from known ones; in short, of proceeding logically from the known to the unknown, using the known as a foundation for the unknown which is sought to be known. Gordy gives us the following excellent definition of the term. Reasoning is the act of going from the known to the unknown through other beliefs, of basing judgment upon judgments, reaching beliefs through beliefs. Reasoning, then, is seen to be a process of building a structure of judgments, one resting upon the other, the topmost point being the final judgment, but the whole constituting an edifice of judgment. This may be seen more clearly when the various forms of reasoning are considered. Immediate reasoning. The simplest form of reasoning is that known as immediate reasoning, by which is meant reasoning by directly comparing two judgments without the intervention of the third judgment, which is found in the more formal classes of reasoning. This form of reasoning depends largely upon the application of the three primary laws of thought, to which we have referred in a previous chapter. It will be seen that if A, a thing is always itself, then B, all that is included in it, must partake of its nature. Thus the bird family has certain class characteristics. Therefore, by intermediate reasoning, we know that any member of that family must possess those class characteristics, whatever particular characteristics it may have in addition. And we likewise know that we cannot attribute these particular characteristics as a matter of course to the other members of the class. Thus, though all sparrows are birds, it is not true that all birds are sparrows. All biscuits are bread, but all bread is not biscuit. In the same way, we know that a thing cannot be bird and mammal at the same time, for mammals form a not-bird family. And likewise, we know that everything must be either bird or not bird, but that being not bird does not mean being a mammal, for there are many other not bird things than mammals. In this form of reasoning distinction is always made between the universal or general class, which is expressed by the word all, and the particular or individual, which is expressed by the word some. Many persons fail to note this difference in their reasoning, and fallaciously reason, for instance, that because some swans are white, all swans must be so, which is a far different thing from reasoning that if all is so and so, then some must be so and so. Those who are interested in this subject are referred to some elementary textbook on logic, as the detailed consideration is too technical for consideration here. Reasoning by analogy. Reasoning by analogy is an elementary form of reasoning, and is a particular kind of reasoning employed by the majority of persons in ordinary thought. It is based upon the unconscious recognition by the human mind of the principle which is expressed by Jevons as if two or more things resemble each other in many points, they will probably resemble each other in more points. The same authority says, reasoning by analogy differs only in degree from that type of reasoning called generalization. When many things resemble each other in a few properties, we argue about them by generalization. When a few things resemble each other in many properties, it is a case of analogy. While this form of reasoning is frequently employed with more or less satisfactory results, it is always open to a large percentage of error. Thus, persons have been poisoned by toadstools by reason of the false analogous reason that because mushrooms are edible, then toadstools, which resemble them, must be also fit for food; or, in the same way, because certain berries resemble other edible berries, they must likewise be good food. As Brooks says, to infer that because John Smith has a red nose and is also a drunkard, then Henry Jones, who also has a red nose, is also a drunkard, would be dangerous inference. Conclusions of this kind, drawn from analogy, are frequently dangerous. Halleck says, "Many false analogies are manufactured, and it is excellent thought training to expose them. The majority of people think so little that they swallow these false analogies just as new-fledged robins swallow small stones dropped into their mouths." Jevons, one of the best authorities on the subject, says, "There is no way in which we can really assure ourselves that we are arguing safely by analogy. The only rule that can be given is this, that the more closely two things resemble each other, the more likely it is that they are the same in other respects, especially in points closely connected with those observed. In order to be clear about our conclusions, we ought, in fact, never to rest satisfied with mere analogy, but ought to try to discover the general laws governing the case. We find that reasoning by analogy is not to be depended upon, unless we make such an inquiry into the causes and laws of the things in question that we really employ inductive and deductive reasoning." Higher forms of reasoning. The two higher forms of reasoning are known respectively as (1) inductive reasoning, or inference from particular facts to general laws, and (2) deductive reasoning, or inference from general truths to particular truths. While the class distinction is made for the purpose of clear consideration, it must not be forgotten that the two forms of reasoning are generally found in combination. Thus in inductive reasoning many steps are taken by the aid of deductive reasoning; and likewise, before we can reason deductively from general truths to particular ones, we must have discovered the general truths by inductive reasoning from particular facts. Thus there is a unity in all reasoning processes, as there is in all mental operations. Inductive reasoning is a synthetical process, deductive reasoning an analytical one. In the first we combine and build up, in the latter we dissect and separate. End of chapter 25. Chapter 26. Inductive Reasoning. Inductive reasoning is based upon the axiom, "What is true of the many is true of the whole." This axiom is based upon man's belief in the uniformity of nature. Inductive reasoning is a mental ladder by which we climb from particular facts to general laws, but the ladder rests upon the belief that the universe is governed by law. The steps in inductive reasoning are as follows: 1. Observation, investigation, and examination of particular facts or things. If we wish to know the general characteristics of the bird family, we must first examine a sufficient number of birds of many kinds so as to discover the comparatively few general characteristics possessed by all of the bird family, as distinct from the particular characteristics possessed by only some of that family. The greater the number of individuals examined, the narrower becomes our list of the general qualities common to all. In the same way we must examine many kinds of flowers before we come to the few general qualities common to all flowers, which we combine in the general concept of flower. The same, of course, is true regarding the discovery of general laws from particular facts. We examine the facts and then work toward a general law which will explain them. For instance, the law of gravitation was discovered by the observation and investigation of the fact that all objects are attracted to the earth. Further investigation revealed the fact that all material objects are attracted to each other. Then the general law was discovered, or rather, the hypothesis was advanced, was found to explain the facts, and was verified by further experiments and observation. 2. The second step in inductive reasoning is the making of an hypothesis. An hypothesis is a proposition or principle assumed as a possible explanation for a set or class of facts. It is regarded as a working theory, which must be examined and tested in connection with the facts before it is finally accepted. For instance, after the observation that a number of magnets attracted steel, it was found reasonable to advance the hypothesis that all magnets attract steel. In the same way was advanced the hypothesis that all birds are warm-blooded, winged, feathered, oviparous vertebrates. Subsequent observation and experiment established the hypothesis regarding the magnet and regarding the general qualities of the bird family. If a single magnet had been found which did not attract steel, then the hypothesis would have fallen. If a single bird had been discovered which was not warm-blooded, then that quality would have been stricken from the list of the necessary characteristics of all birds. A theory is merely an hypothesis which has been verified or established by continued and repeated observation, investigation, and experiment. Hypotheses and theories arise very generally from the subconscious assimilation of a number of particular facts and the conscious flashing of a great guess or a sacred suspicion of the truth into the conscious field of attention. The scientific imagination plays an important part in this process. There is, of course, a world of difference between a blind guess based upon insufficient data and a scientific guess resulting from the accumulation of a vast store of careful and accurate information. As Brooks says, the forming of an hypothesis requires a suggestive mind, a lively fancy, a philosophic imagination that catches a glimpse of the idea through the form or sees the law standing behind the fact. But accepted theories, in the majority of cases, arise only by testing out and rejecting many promising hypotheses and finally settling upon the one which best answers all the requirements and best explains the facts. As an authority says, to try wrong guesses is with most persons the only way to hit upon right ones. 3. Testing the hypothesis by deductive reasoning is the third step in inductive reasoning. This test is made by applying a hypothetical principle to particular facts or things, that is, to follow out mentally the hypothetical principle to its logical conclusion. This may be done in this way. If so and so is correct, then it follows that thus and so is true, etc. If the conclusion agrees with reason, then the test is deemed satisfactory so far as it has gone. But if the result proves to be a logical absurdity or inconsistent with natural facts, then the hypothesis is discredited. 4. Practical verification of the hypothesis is the fourth step in inductive reasoning. This step consists of the actual comparison of observed facts with the logical conclusions arising from applying deductive reasoning to the general principle assumed as a premise. The greater number of facts agreeing with the conclusions arising from the premise of the hypothesis, the greater is deemed the probability of the latter. The authorities generally assume an hypothesis to be verified when it accounts for all the facts which properly are related to it. Some extremists contend, however, that before an hypothesis may be considered as absolutely verified, it must not only account for all the associated facts, but that also there must be no other possible hypothesis to account for the same facts. The facts referred to in this connection may be either (1) observed phenomena, or (2) the conclusions of deductive reasoning arising from the assumption of the hypothesis, or (3) the agreement between the observed facts and the logical conclusions. The last combination is generally regarded as the most logical. The verification of an hypothesis must be an all-around one, and there must be an agreement between the observed facts and the logical conclusions in the case. The hypothesis must fit the facts, and the facts must fit the hypothesis. The facts are the glass slipper of the Cinderella legend. The several sisters of Cinderella were discarded hypotheses, the slipper and the sisters not fitting. When Cinderella's foot was found to be the one foot upon which the glass slipper fitted, then the Cinderella hypothesis was considered to have been proved. The glass slipper was hers, and the prince claimed his bride. End of chapter 26. End of section 11.